Good afternoon, my YouTube viewers. In this particular video, we're going to be covering the central limit theorem, which is a recap on previous videos. But we're going to go ahead and run over it again. And basically, the central limit theorem states that it doesn't matter what the original distribution is. If you take enough samples of the original distribution, then the means of those samples will be a normal distribution. And so what we're going to do is we're going to prove the central limit theorem by taking an original distribution as being an exponential distribution. So we're going to import the libraries that we will need to execute this program, being NumPy as MP, which is the numeric library, and we're going to import matplotlib.pyplot as PLT, being the visualization library. So we're going to define our parameters. So population size is 100,000, and population equals np.random.exponential brackets scale equals 2, comma, size equals population size. So it's a non-normal distribution, and scale is going to be your standard deviation. So we're going to set the sampling parameters as a sample size of 30 and the number of samples being 1,000. So in order to collect the sample means, what we're going to do is we're going to define the variable sample means, which is an empty list. And then we're going to create a for loop, which is going to iterate through the loop 1,000 times for 1,000 different samples. So for underscore in range num samples, sample equals np.random.choice brackets population comma size equals sample size, so that's 30, comma replace equals false, so that means that whenever it takes a sample it doesn't replace it. And then sample means dot append brackets np.mean sample. So what it's going to do, it's going to append the mean of the sample to sample means, and it's going to do that 1,000 times. So whenever the for loop has completed its iterations, you will have a list of 1,000 sample means in it. And then so what we're going to do now is we're going to plot the population distribution, and after we plot the population distribution, we're also going to plot the sampling distribution of the sample mean. So plt.figure brackets fig size equals 6, 4, and then plt.subplot brackets 1, 2, 1. We're going to plot a histogram. So plt.hist brackets population, comma, bins equals 50, comma, color equals light blue, comma, edge color equals black, comma, alpha equals 0.7. And so the population is the exponential distribution that we had made earlier on in the program. So the title is population distribution exponential because it's an exponential distribution. The X label is value and the Y label is frequency. So now what we're going to do is we're going to plot a distribution of the sample mean. So plt.subplot brackets 1, 2, 2. We're going to the distribution is going to be in the form of a histogram. So plt.hist brackets sample means, comma, bins equals 30, comma, color equals light green, comma, edge color equals black, comma, alpha equals 0.7. The title is sampling distribution of the sample mean, and the X label is sample mean, and the Y label is frequency. So the PLT plt.type layout and plt.show means we are going to show the two distributions. So you can see that we've got the first distribution is an exponential distribution, and the second distribution is a normal distribution, which is derived from 1,000 sampling sessions of the exponential distribution. So that just proves that it doesn't matter what the distribution is, and you can see here that we've got the exponential distribution. Whenever you sample the distribution, the means of the sample distributions will form a normal distribution. And so basically we have proved the central limit theorem in this video. So thank you so much for watching this video. The next video we will be talking about some more statistical concepts.